The majority of the world's population resides in temperate climates, shown in green. Chicago is one of the cities located in a temperate zone, having 4 distinct seasons. To be thermal comfortable, people try to avoid the wind in the winter and to deal with the high solar radiation in the summer. The current prevailing method in temperate climates to address human comforts is to use active systems. Active systems use mechanical means to artificially cool or heat a place. Right now, these active systems still largely rely on finite resources, such as natural gas and electricity from not renewable sources. We need active systems in temperate climates to deal with the extremes. However, the use of them all the time consumes a lot of energy, making buildings the sector that consumes most energy in the US. Through microclimate design, we can think differently. Macroclimate interacts with local landscape to produce microclimate. Modifying microclimate through design affects energy use, human comfort, water management, landscape, and economics. Through microclimate design thinking, our team wants to create new relationships between energy, human experience, and shelter. We also want to minimize the use of active systems by increasing the contribution of passive systems and building configuration. Based on our research and analysis, during synthesis we developed the concept for a demand-responsive environment that is composed by real-time sensing of factors, elements that move to adapt to conditions, closed-loop energy and water, and localized zones to heat or cool people instead of entire spaces. We applied this approach to 2 studies in line with City of Chicago's 2016 Lakefront Initiative, the 31st Street Harbor, and a floating mobile park in Lake Michigan. Both studies apply demand-responsive criteria and use passive systems and building configuration to reduce solar radiation in the summer and wind in the winter. In addition to that, both studies consider closed-loop systems for water and energy. With all the strategies used, we think that the overall electricity and water consumption can be reduced in 80% when comparing with conventional methods. In addition, we minimize the use of active systems and retool them to run on renewable instead of finite sources.